Hey guys, welcome back. So what we are looking at today is lesson 13. So let's go ahead and jump right in. So siblings in the house. Here's a table that shows the number of siblings of 10 students in Tyler's class. So we've got 1, 0, 2, 1, 7, 0, 2, 0, 1, 10. So we want to represent the data shown in the table with a dot plot. So we're going to start by making our dot plot, and I'm going to make mine up here in this corner where I have a little bit more space. So all the way across there. So we've got our 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so we've got 1, we have a 0, we have a 2, we have another 1, we have a 7, we have a 0, we have a 2, we have another 0, we have another 1, and we have a 10. All right, so there is our dot plot that represents this data. So for number 2, based on our dot plot, estimate the center of data without making any calculations. What's your estimate of a typical number of siblings of these 6th grade students? Mark the location on your dot plot. So if we look at this, where about would our average, our estimate of center be for this dot plot? Probably somewhere between 1 and 2, just a hunch. So we're going to make a little triangle between 1 and 2. So between 1 and 2. Now we're going to actually calculate the mean. So if we take 1 plus 2 is 3, plus 1 is 4, plus 7 is 11, plus 2 is 13, plus 1 is 14, plus 10 is 24. So we'd have 24 there when we add them all together. So it's going to be 24 divided by, it says that there's 10 data points. So that means it's 2.4. So almost 2.5. So for 4, how does the mean compare to the value that you marked on the dot plot as a typical number of siblings? Is the mean you calculated a little larger, a lot larger, exactly the same, a little smaller, or a lot smaller? So if we look, we're at 2.4 versus somewhere between 1 and 2. So we're not a lot larger, so we are a little larger. A little larger. So for B, do you think the mean summarizes the data well? Explain. So is this mean a good representation of this data? No. 8 out of, oops, that's not of, oh, gracious. Hang on. There we go. 10 students are below the mean. More than half have 0 or 1 sibling. So 2.4 is not accurate. It's a lot higher. If we think about the fact that most of them have either 0 or 1 sibling, 2.4 is significantly higher than 0 or 1. And that's where most of our data is at. Sorry. So it's not a very accurate representation of this data set. So sometimes the mean isn't our best bet. So we're skipping number 1. Number 2, here's the data set on number of siblings from the previous activity, so the one we just did. We're going to sort the data from least to greatest and then find the median. So the median is another form of center. Median is also your keyword for this lesson. Okay, so we've got 2, 3 zeros. So we've got 0, 0, 0. Then we have 1, 2, 3 ones. 1, 2, 3. Then we have 2 twos. So there's 2, there's 2 there and there. So 2 twos. Then we have our 7. And then we have 10. All right, so there is our data from least to greatest. Now what we're going to take and do is find that median. So finding the median means we find the middle number. So we cross them off from either end. So we've taken 1 off each end. Now we have 2 off each end, 3 off each end, 4 off each end. Now, we've done an even number of them, so we've got 4 on this side and we've got 4 on this side. So that means there's 2 numbers that are the middle of our data. So we're going to add 1 plus 1 together. We get 2. We divide by 2, which just gives us 1. So that means our median is 1. So for B, in this situation, do you think the median is a good measure of a typical number of siblings for this group? Yes. Most students have 0 or 1 siblings. So it's more accurate to the set of data. So sometimes the median is our better center rather than using the mean. All right, for 3, here is the dot plot showing the travel time in minutes of Elena's bus rides to school. Find the median travel time. Be prepared to explain your reasoning. So if we take a look, we want to find the median. Now, because it's in the dot plot, this is already in numerical order. So we're going to take off our values from either end. So we've got 2 on this side. Now we're at 2 on this side. 3 and 3. 4 and 4. 5 and 5. So once again, we have 2 values in the middle. So we've got 8 plus 9 equals 17 divided by 2, which is going to give us an 8.5. So the median is 8.5. Now, what does that tell us in this context? So that tells us that the median tells us that half of her trips to school took 8.5 minutes or less, and the other half took 8.5 minutes or more. So median is right in the middle. It's showing us a perfect middle or a perfect half of our data set. So a lot of times we use the median when we have an outlier. it makes our data more accurate to the actual values. So like we have this outlier of 12 up here with siblings, we had an outlier of 10 and even 7. So we had those two outliers compared to the rest of the data. So it gives us a more accurate representation of our data set sometimes, especially when we have outliers. All right, so remember your keyword for this lesson is median. Have a great week and happy mathing.